So yes, my dear friends, we are back again. As I have been telling to you, we are parallelly going with two different subjects. One is engineering, procurement and commissioning of 66 by 11 kV substation. And the second one is the transmission line protection using overcurrent and earth fault relays. Yesterday we talked on EPC, that is engineering, procurement and contracting commissioning. Up to session 3, we have seen different activities and we have seen the bus bar arrangements also, right? And then we have seen the we have seen the bus bar arrangement, how to decide the land acquisition, what area we will require, and how we will place different equipments. We have seen the layout, that is as seen from top, three-phase view, and we have also seen the detailed single line diagram, which will let you know about the substation. So now in this session, we are starting the engineering further. Engineering, procurement, commissioning, contracting of 66 by 11 kV substation, session 4. I have given my numbers also. So if you feel that you find any difficulty in understanding anything, you are most welcome to ask questions. This YouTube video is also free of cost. And if you ask me a question, it is also free of cost. Do only one favor, that first send a WhatsApp message and let us decide the mutually convenient time so that you or me is not disturbed. Or it may so happen that in the noon time I'm sleeping, I'm making my mobile silent, that so that I may not be able to hear your call. So first it would be better that you send me a WhatsApp, or email is also equivalently good. I have sent an email address also. So in this engineering we start with, you see, you will have to tell what incomers will come. That you should tell as a part of engineering. Before that, before 66 kV line, 132 by 66 kV substation is there, that we are not talking right now. We are talking about 66 by 11 kV. But two incomers are coming. So you have three transformers of 15 MVA. So it makes 45 into 10 raised to 3 divided by root 3 and divided by 66 is going to be the current for three transformers. But incomers are 2, so I am dividing by 2. So for my one incomer, the current is 196.82. I was telling to you that this incomers are SCSR conductors. Central conductor is steel and around there are aluminum strands. And the stranding etc. also we will be seeing today. The name of these conductors, I don't know what is the reason, but they are behind the names of birds and animals. Standard conductors SCSR are zebra, mole, tiger, uh, rabbit, and squirrel. Like that, the conductors are there. Reason I don't know. But Once you say I'm using a tiger conductor, its dimensions are fixed and everything is fixed. It is a standard conductor. So everything about that conductor, the table is giving. I wanted to put the table but for some reason I have forgotten to put the table. But I can tell you that there is one book, uh, powers, I mean, elements of power system engineering by M.V. Deshpande. In that book, he has given the table. I obviously the table is taken from Indian standard, so you can refer Indian standard also. But here, whatever we are using, that I am going to give you. So when 196.82 ampere is the current, you have to go for the standard conductor, which is having, I mean, which can take current more than 196.82. That is very obvious. And that conductor is rabbit. So we are going to use rabbit conductors for two incomers. Specification standard given. Nominal copper area 30 mm square. Equivalent area of aluminium 52.21 mm square. Resistance at 20 degrees. You see, that is very, because I square R losses you are going to count. So they are giving resistance at 20 degree. 0.54490 ohms per kilometer. And they will be giving the temperature coefficient of resistance and the prevalent temperature you can measure. So prevalent resistance also you can calculate using the uh, temperature coefficient of resistance. So that you will see it will be given. Resistance is this. Approximate current carrying capacity is 208 ampere. See, 196 I want and I am going for 208. Stranding and wire diameter. What are the stranding and wire diameter? So for aluminium there is on for aluminium there are 6 strands and diameter of each strand is 3.35 millimeter. Middle conductor is steel, strand is single and diameter is 3.35 millimeter. This is the standard. And if we go further, the conductor diameter, total conductor diameter is 10.05 millimeter. Conductor area from diameter you can consider 61.70 mm square. Approximate weight, because you see while deciding the uh, what is known as between two spars, there will be sag. So while calculating sag, because sag will be there and therefore based on sag you will have to think of the ground clearance. So weight is very important. So aluminium weight is 145 kg per centimeter square. Steel is this and total is given. Approximate ultimate strength. That means that this 1860 kg, the conductor will break. So if you go on stretching, if you don't allow sag, then the conductor will break. That should not happen. Not only that, but you will keep some factor of safety. That is discriminatory. You may keep 2, you may keep 3. That means if you keep 3, then you will allow strength 1860 divided by 3. Temperature coefficient of resistance at 20 degrees centigrade is given. So at prevalent temperature you can find out R and you can find out I square R losses. Modulus of elasticity is also given. So this much is for two incomers. For three transformers, it is 15 MVA. Current is 131.216. And for this, we will use gopher conductor because that matches. Specification once again. Nominal copper area 16 mm square. Equivalent area 25.91. Resistance at 20 degrees centigrade. This approximate current carrying capacity 133 ampere. You see, I am going higher. Stranding is also given. Stranding is for steel, I am using 1 strand. The diameter is 2.36 mm. For aluminium, 6 strands. and it will be 2.36 mm for single strand. Then the further specification is total conductor diameter is 7.08 mm. Conductor area is 30.62 mm square. Approximate weight for aluminium is 72 kg per kilometer. Steel and total it is given. Approximate ultimate strength 952. Temperature coefficient at 20 degrees centigrade and modulus of elasticity. So all these things are standard. They are given. So we have prepared the specification of the SCSR conductor for 3 incomers and 2 transformer feeders. Then but PT is also fed. PT is taking milliampere. So I mean milliampere feeder will not be available. The minimum what is available is mole. So we are using mole. Specification are same 6.5, 10.47, 2.79, 40 degrees. Stranding is given. And then if you see conductor diameter 4.5 millimeter only, approximate weight is given, and the uh, the current is very small, but it will be some tens of amperes, 52 ampere or 53 ampere. I don't know why it is not given. Uh, uh, it must have been given. Uh, Approximate current carrying capacity at 40 degrees centigrade. It is forgotten. But it is not a question because it is taking only certain millimeters, sorry, certain milliamperes. So this will easily be able to take, and that small conductor is not at all available also. So all these things are for that PT. So now for 66 kV side, you have decided the conductor specification, and you will be able to, I mean, procure that. I mean, procurement procedure, we have said that you will give an advertisement in paper and then tenders will come and then you will decide the person from whom you will purchase. That we have already decided. But these are the specifications. According to these specifications, you will go. So this was important. No doubt on 11 kV side also it is important. You have to use XLP cables. But I did, books are not giving. ISS have to see that they might be giving by now. But XLP conductor manufacturers also must be giving. For 11 kV, you are going to use from transformer secondary onwards. You are using XLP cables. For outgoing feeders, you are using up to first pole because the substation is inside and first pole will be outside. So up to first pole, you are using the uh, XLP cable. XLP cable, unfortunately, I have not given the diamond, I mean the specifications. So leaving that, we are going now further. Further means we are talking about the first equipment now. Lightening arrester is the first equipment. So before we talk about that first equipment, all those many viewers who are having 20 years of experience or 30 years of experience might be knowing everything about lightning arrester, how lightning arrester works, that also they might be knowing. But sometimes so often that also happens. One of my students who passed in 1990, he told that now I have started forgetting many concepts because now he is on management cadre, he is thinking of big things. So that way, for those who are experienced also, this may be useful. Their concept will be, they have studied, so they will be easily able to catch up. But their concepts will be clear. And those who are new, those who are students, they are learning for the first time. So this is very important. Many of these things are given in the book. I don't say many books are available, but I have compiled from different books and have served also, have seen also substation. So based on that, I am doing. So first thing, that lightening over, I mean lightning arrester is required to protect against lightning over voltages. Lightning over voltages are known as external over voltages also. You do not have any control over them. It is not generated from transmission line. It is not generated from your power system. It is generated from external reasons. So to say, God generates, if you want to say so. But then, anyway, people have prepared the theories. What happens that in monsoon season there are clouds and clouds are moving, and when clouds are rubbing, because of rubbing action, the cloud gets charged. So charged means Q, and between cloud and ground there is air, that is capacitor. So whenever there is Q and C, V is there, right? And that V, my dear friends, it is as large as 1000 kV, 1000 kV. So no equipment, no transmission line, nobody can withstand. Therefore, this over voltage has to be grounded. One thing, and as we shall see, it is not only the question of the magnitude, it is the question of the rate at which 1000 kV is rising. The voltage of 1000 kV is rising within 1.2 microseconds. So it is rising so fast. It's an impulse voltage. So it's very dangerous. Uh, Insulation of the equipment will be damaged intrinsically, and not only intrinsically, but it will be damaged within 10 raised to minus 6 to 10 raised to minus 8 microseconds. That means 1 or 0.01 microsecond. So very bad, right? So it has to be grounded. You have to protect. So this is what I told, right? That the uh, lightning is developed because of rubbing action of two clouds. Certain other details are given, not very important, but you can go through, you can pause the video and you can read these things. Whenever lightning stroke falls on ground or transmission line or whatever, then very large current also passes, right? And that large current is very destructive. If it falls on plain ground, it will create an 8 feet uh, pit, 8 feet deep pit within 1 microsecond. You can think of, you start digging the pit of 8 feet deep. It will take, I mean, for Mazdurs also it is taking 4-5 hours or a day. This is within 1 microsecond. So enormous energy is there in lightning stroke. That was what I was going to tell. And once the lightning stroke comes to ground, it comes to ground slowly, because you see the air between, when monsoon season is there, obviously clouds are heavy, so they will come down. So distance is less. So the air will break down. But then again, the charge may become less. Charge, the cloud goes away, charge becomes less. This is all not sure. I mean, it is, you cannot say for sure that this. So lightning may come up to 1 meter and then go away. So it may not strike the ground. But if it continues, that means yet the cloud is there, that much voltage is there, and because of that, the uh, that uh, current, that is the stroke, comes still down like that, and it touches the earth. But it touches the earth in a stepped way, therefore it is known as stepped leader. But once the step leader is there, it is a continuous leader. Now the path is paved. So if the uh, voltage gradient remains, it retains, then repeated stroke can occur. I mean, 3 repeated strokes have been observed. There are many laboratories all over the world. They are measuring the voltage of lightning. They are measuring the current of lightning, and they are measuring the number of repeated strokes also. And repeated strokes are harmful because if 3 times the lightning falls, then it will damage the uh, it will damage many things. Say, first thing, it can damage the very tall buildings, 12 story, 14 story, and now a State Empire building, 105 story, and yet higher buildings are now there. So those buildings will be, may collapse or there may be cracks. So that they may be damaged, one thing. Second thing, the earth, there will be pits and all. Some person is there, then that person will die. And if it falls on transmission line and substation, then the insulation will certainly rupture. So, this is the consequence of lightning over voltage. It is high frequency and high magnitude over voltage. Therefore, you have to protect against that. And for that, we should understand what this is. So, understanding further, those types of strokes are uh, direct strokes. Direct strokes means the strokes that come up to the ground, from cloud to ground. That is direct stroke. In that also there is stroke A and stroke B. And the second type of stroke is induced stroke. Direct strokes are very rare. Induced strokes are very common. Induced stroke means the stroke does not fall up to ground. But because cloud is charged, say positively, cloud can be positively charged, can be negatively charged. Which cloud can be positively charged? Which cloud can be negatively charged? So many physicists have done quite a lot much of research work, but we need not go into this because we are application engineers, so we do not go into theory. But if cloud is positively charged, then it will induce negative charge on ground, on transmission line, any grounded object, right? That is the induced stroke. So what is stroke A? So stroke type A, that we have already rather explained, that it comes in a stepped way and then it will go in a repeated way. Usually repeated stroke does not occur. Once the lightning occurs, the uh, charge will be neutralized and cloud will be having no charge. So repeated stroke is very rare because it will occur because that charge is cloud is positively charged, ground is negatively charged, direct stroke has occurred, current flows from ground or grounded object to uh, cloud. So negative and positive will meet and it will be neutralized. So possibility of repeated stroke is rare. But if some another cloud is nearby, which has got a bulk of charge, and now this charge, this cloud is neutralized. So there is a pit. There is a possibility of charge coming to that cloud again. So then repeated stroke will occur. But very rarely they have occurred. As I told you, in the history, it is 3 till date. So that is direct stroke. Direct stroke type A. Direct stroke type B is very dangerous. What is direct stroke type B? This is direct stroke type B. I have got two clouds, B and C. B is negatively charged. Therefore, C is positively charged by induction. Now, that induces the charge on the transmission line. I have shown the transmission line in a symbolic way, but it so the charge on the transmission line is negative by induction, but it is bound. It is bound by cloud C. So because it is bound, it cannot do any damage to insulation because it is bound. One charge has created another charge. It is bound. But now so happens some third cloud A comes nearer to B and there is an internal or in the air. There is a stroke between A and B. Positive and negative getting neutralized. So the positive charge on C becomes abruptly free. So negative charge that was induced on transmission line becomes abruptly free. And that which gets abruptly free, you do not have time to take it to ground. Therefore, this uh, stroke type B is very dangerous. You cannot have protection against that. But fortunately, that is also very rare. Induced are very common because induction will occur. So, after all, what you have to think is you have to think about the protection of insulation of transmission line or any equipment against basically induced lightning stroke. So, induced lightning stroke is explained here in figure 3.2. I have got a positively charged cloud. So, just below that transmission line is negatively charged. But as you see, we have got magnet. One pole is north, one end is north, another end is south. Similarly, here the the line which is away from the cloud will be positively charged. Line just below the cloud is negatively charged. That positive charge is not bound. It is free. So it will slowly leak through the insulation of the line. So it is not going to damage. It is not a big question. We are not worried about that. We are worried about that bound negative charge on the line. Because cloud is not going to remain there. Because of air it will go away or some another cloud will come and there will be internal lightning stroke and that cloud will not be there. So that negative charge becomes free. It was not direct stroke. So that negative charge travels over the line because after all line is conductor. Stroke is also electrical thing. So it travels on both sides of the line. And while traveling, it stresses the insulation. And when it stresses the insulation, our duty is to protect the insulator against this voltage stress so that the insulation is not damaged. Because monsoon season is there, uh, clouds are going to come. This is there. So right now we are talking about monsoon season, but in time to come we will talk about switching surges also. So switching surges are available in all seasons. They are also like lightning stroke. Difference is only in its characteristic that we will see later. But right now we are seeing this is induced stroke, right? And you have to think about protection of insulation against this induced stroke. So if you see the parameters and characteristics, you can read through. So I'm not going to through this. You can uh, read through these items. I mean, just uh, it is it is written in books, and certain things are important. So I've given that. But uh, this overvoltage is passing through line, so it is stressing all insulations, all string insulators, right? And you have to protect all string insulators. Otherwise, there will be a flashover and there will be earth fault and line will trip. If you do not want line to trip, you have to protect the uh, line insulators against this. So protecting that, there are three things that you have to do. It is not three methods. All the three things you have to do. Shielding the overhead lines by using ground wires and ground wires above the phase wires. You might have seen, if you have seen the transmission line, three lines are on one side, suspended by insulator. taking power, 3 on the other side in parallel conductors. But at the top, one wire without insulation is running. That top wire continuous running from one end to the other is for protection against lightning or voltages. But that conductor is connected to iron tower. Iron is not good conductor, very good conductor of electricity. So that ground wire has to be connected to pakka ground. Ground wire has to be connected to very clear cut ground so that the soil resistance or resistivity is less. So for that you have to use ground wires or counterpoise wires. And third thing that in certain cases, if it is very important, people use expulsion gaps and protector tubes also. And yet fourth thing I'll be showing is the shielding angle. So these four things will protect the line insulators against the lightning stroke. Line insulators are not very costly, so you cannot use a lightning arrester. One lightning arrester is about 5 lakhs. There are 3 RYB, so 15 lakhs. You cannot spend for line insulators which are not that very costly. So we are using so much for line insulators. Uh, then if we refer to figure 3.5, uh, how do we protect the uh, line insulators against lightning stroke? So this is the figure. This is the figure. Cloud is there. Obviously, between cloud and ground, the distance is large. And there is air. So capacitor C1 is air capacitor. And the voltage between cloud and ground is V1. D is a phase wire. It is very near to ground because it is suspended by line insulator. The epsilon which you call is 1 for air, but epsilon for the uh, line insulators, that is the ceramic insulators, is high. And the distance is also low. And the capacitance, value of capacitance is inversely proportional to distance. So C2 is very high with reference to C1. And lightning stroke has fallen. So current I as shown is passing. And it is because of same lightning stroke. So value of current I is same. So now if you write an equation, the equation will be like this. It is written here or it is written above. It is probably written above. V1 is equal to I1 by omega C1. V2 is equal to I2 by omega C2. So I1 is equal to V1 omega C1. Sorry, I is equal to V1 omega C1. Same I is equal to V2 omega C2. So V1 omega C1 is equal to V2 omega C2. Omega is constant. So V1 C1 is equal to V2 C2. And as I told you, uh, C1 is very small and C2 is very large. So V1 C1 equal to V2 C2. When I say C1 is small and C2 is large, so V2 V1 C1 multiplication is same. C1 is small, so V1 will be large and V2 will be small. And if you see this figure, if you see this figure, V2 is small and V1 is large. That means the voltage between cloud and ground wire is large. And ground wire is grounded, so that voltage is going to ground. And V2 is small. That is the voltage stress across the line insulator is small. So this is how, by using ground wire, I am protecting the line insulator. I am making V2 small. The figures before that I have shown is a transmission tower. theta s is the angle, you see, between tower, I mean ground road and the resistance. You see, central line is created, you can see theta s. Theta s is known as sending angle. Theta s should be 30 degree or less. Then your lightning protection will be better. So this is one more requirement. And these are the waves, traveling waves. They are traveling. This is the forward travel and this is the reverse travel. So uh, voltage and current both are traveling on the line. And when voltage travels, it stresses the insulator, and high current is also passing. So this one has to remember. This was what we were telling. So this is how the uh, so to say the uh, line insulators are protected against lightning stroke that falls in the uh, monsoon season. But otherwise also, when switching surges will be there, they are also protected in the similar way. But as I told to you, those ground wire that is at the top has to be connected to ground. You may not connect at every pole, but after every 10 poles or 5 poles, you will have to connect that wire to ground. Connecting the top wire to ground, there are two methods. One is ground wires. It is shown. Right. Between two ground wires, there is a distance x and distance y. That is x and y distances. And the diameter of the ground wire. This is a method of design. This is designing the grounding system is very costly, very complicated, and usually designing the grounding system, the consultants are there and they are charging very high amount. Depending upon how many ground roads they have to do, they may charge from anywhere from 1 lakhs to 10 lakhs. We are not going into the design of these things, but we are talking that ground roads have to be laid. These ground roads have to be laid at the mirror reflection of ground wire, top ground wire. That means you have to um, dig a pit as deep as the height of the tower. So digging is costly, no, obviously. But only one, there's so much ground wire is enough. But people prefer counterpoise wires because the system is cheaper, right? Counterpoise wire, I have not shown the figure, but counterpoise wires you can lay on ground also. But people do not lay on ground because somebody will I mean, there can be a theft. So half a meter uh, pit is dug and counterpoise wire is run on on I mean on the ground, half a meter under the ground. Between two poles, one third distance from one pole and one third distance from another pole. There will be one third distance. There will be no I mean counterpoise wires. But between second pole and third pole, third and pole and fourth pole, counterpoise wires will run. And your top ground wire has to be connected to either ground roads, ground wires, or to the counterpoise wires. So this makes, that means the top ground wire non-stop continuously throughout the length of the line, ground roads or counterpoise wires, and shielding angle. This completes the protection of line insulators against the lightning strokes. Yet we have not gone to substation because the direct stroke may fall on substation also, and if it does not fall, if it falls on line, As a traveling wave, it will come to substation or power station. There is a theory of traveling wave also. It is mathematics. We are not going into that. That is also given in books. But the wave travels. No doubt, while the wave is traveling, it will be, the magnitude will be less because some uh, current will leak through uh, the line insulators, and because there is a length, the wave shape will also change. So when it reaches to the substation, it will not be that bad. That means if the lightning stroke has fallen some 100 km away, then by the time it reaches substation, it will not be that bad, right? But it is not sure that it will be 100 kilometers. It can be 5 kilometers, it can be 1 kilometers, or it can be 10 meters also. So you have to be ready for the worst thing. So in that case, you have to protect the equipment in substation, and equipment in substation are much more costlier than the uh, line insulators. So the protection that we provide for that is more complex, more complicated, more costly. So that we have talked. We will see the wave shape that I was talking to you. Wave shape of lightning stroke is like this. It reaches from 0 to VP peak. V peak, as I told you, is 1000 kV more or less. And then it will go away. It will diminish. It will go on diminishing. So T1, the time within which it reaches VP, is 1.2 microseconds. So that is very bad, very high voltage, and that is reaching within very short time. Therefore, the insulation can be intrinsically damaged. So that is the reason why we are very particular about protection. Then it will go on diminishing, and complete lightning stroke will diminish within about 1000 microsecond. That is 1 millisecond. So it is, I mean, within 1 millisecond, no relay will operate. So even if you are grounding using the ground wire or something, you are grounding the electricity. But when you are grounding the electricity, you are grounding only for 1 millisecond. So no earth fault relay will operate, and it should not operate also. Otherwise, in monsoon season, you cannot run the electricity. So because of lightning stroke, the relay does not operate. That is very obvious. But we do not define the lightning stroke for 1000 microsecond. It is defined like this, that from Vp to Vp by 2, half the voltage will reach within time T2. That is OT1 and OT2. O is the origin. OT1 is 1 microsecond, 1.2 microsecond. It is not so that it is 1.2 microsecond. The statistics have told that real lightning uh, discharge uh, reaches to peak varying from zero point 0.8 microsecond to 1.2 microsecond, 0.8 to 2. But the the uh, standard, Indian standard or any standard has to define. So we have defined 1.2 as a peak time. That is known as peak time. And T2 is known as tail time or T2. That is 50 microsecond. The actual variation is from 48 microsecond to as good as 60 microsecond. But we have defined 50 microsecond. So OT1 is 1.2, OT2, that is a tail time, front time and tail time. This is the characteristic of lightning stroke. It is an impulse wave. It is not sinusoidal. So you are protecting against this. So that C1, C2 is more than C1, therefore V1 is more than V2. So how we are protecting, shielding angle, all these things I have explained. So I am skipping through. How we are laying ground wires and counterpoise wires, that also I discussed. Second method is cheaper counterpoise wire. So usually it is that is used. That also I have discussed. So I'm skipping through. With reference to system voltage, what is the allowable resistance of tower? Using ground rods and counterpoise wires also there will be some resistance. So for 11 kV lines 2 ohms is allowed. For 33 kV 6 ohms and for 132 kV 50 ohms. So these are the resistances allowed for so that the lightning is not that bad, right? Because you see, when the current is passing through this resistance, uh, 10,000 ampere of current is passing. So tower top is also at high voltage now when lightning stroke falls. So tower top can be at a voltage more than the system voltage. Then there will be back flash over from top to the wire, back flash over. So you have to think about protection against back flash over also. I mean, the same thing that we are using will work there. But one should know that there can be back flash over also, because 10,000 ampere is flowing through tower multiplied by tower resistance that I have given here. So the tower top will be at the high resistance. The ground wire which we told will be at the high voltage, and it can be higher than the system voltage. Say if it is 66 kV, then it will be certainly higher. But if it is 765 kV, 700 kV, then there are less chances of back flash over, because system voltage itself is high. So that. Counterpoise wires. How do we lay that I have discussed about. So I don't talk about that, right? Uh, uh, with that, we end today's talk. Probably the talk has gone as long as hour. Once I will see when I started recording and when I stopped, I'll come to know. But this is very important. And with this, we are covering over voltage protection also, as overcurrent protection is there. Over voltage protection is also equally important. Stay tuned with Adapt Me. Don't forget Adapt Me. And remain with that. Uh, Read these videos, because this knowledge is not very easily available. It is rarely available, and it is available free of cost. And if you read, you will pay me. So your payment will not be in terms of money, but in terms of read hours, in terms of how many. I mean, if one person reads for half an hour or 1 hour, then I will get one read hour, right? So if I reach up to 4,000 read hours, the YouTube pays me, because right now also YouTube is putting advertisement in my videos, but they are not paying me. But afterwards, after 4,000 view hours, they will pay me some percentage of what advertisement they get. So I will be getting payment after 4,000. So my immediate goal is 4,000 viewers. And that 4,000 viewers I cannot do. You have to help me out. You are going knowledge. So in answer of knowledge, you don't pay me in terms of money, but you can always pay in terms of reading the material. I mean, hearing the material, seeing the video for full time and understand this, right? That will pay me. If you just see for 1 or 2 minutes and like it, then likes are there. You have seen for 1 or 2 minutes, therefore view is there. My views are more than 30,000, 40,000. But unfortunately, the view hours are hardly 1,000, just to reach up to 4,000. So uh, my viewers all throughout the world, all intelligent and sincere viewers, are my ambassadors. They are my marketing engineers. You have to uh, make the name of Adapt Me to rise high in the sky, and uh, you have to see to it that there are certain million views of our videos, certain lakhs or millions of viewers, and millions of likes without any cost, but that pays us in that way. So remember Adapt Me, remember Aptrace, don't forget us. Thank you very much for hearing me for such big long time, because whatever I am speaking is complex, sometimes tedious also, but very important if you are in this field. That means if you are in the field of lightning arresters, if you are in the factory that is manufacturing lightning arresters, if you are in substation maintenance group, if you are in transmission group, say in Gujarat Jetco, then all these things will be going to be useful. So please use this, share to as many technical friends as yours, right? Some students are telling that we are not in field, so we are not reading. Okay, don't read, but see at least for 2 minutes or half a minute. I will earn views and like, so that people know Adapt Me, right? So that can always be done. So do at least that if you are not in this field. But if you are in this field and if you are a student, no book will give you so much of material. So please be with Adapt Me. Thank you and good day.